Welcome back. So now we have a sort of pickup or an item that we can at least strive to try to capture, and they keep popping up. And as we're playing, we're going to be dodging laser beams, basically, from the drone, right? So it's going to be a little challenging to try to capture these as we're dodging bullets, so to speak. However, as soon as we grab one of these, well, it disappears and nothing else happens. And typically in a game like this, you would keep count of a sort of score, some kind of achievement, a count of how many of these spheres that you've captured. Now, in order to do that, you have to have a class to store that data on, some kind of actor, perhaps. Now, there is a class that each Unreal Engine game project will have. It's called the Game Mode class. The Game Mode has several responsibilities. For one, it typically keeps track of the rules of the game, how to win, how to lose, etc. It also determines what class to spawn for the default pawn. Now, if we go to our world settings, there's a section called Game Mode, and there's a property called Game Mode Override. By default, it's set to none. In other words, there is no specified game mode set for this world, this level that we're in. We can choose a game mode class from the dropdown, and there are a couple of options, but we can create our own game mode class. I'd like to do that so that we can see what a game mode class blueprint looks like. And then perhaps we can keep score on the game mode. So let's go to our blueprints folder, and we'll make a new folder here. I'm going to call it game. And in the game folder, we're going to create our game mode class. So we're going to right click, choose new blueprint class. And for the first time, we're going to choose a class other than actor. We're going to go down to game mode base. Now, game mode base is a base class that we can create our blueprint based on. And you can see the description says the game mode base defines the game being played, its rules, scoring, and other facets of the game type. So we'll have this game mode base that will persist throughout the time we spend in our level. And if we go ahead and select that, we can give it a name. We're going to call this BP Bad Bot Game Mode. And we're going to open up BP Bad Bot Game Mode. And as you can see, it looks a lot like an actor blueprint. That's because game mode is based on actor. So it inherits all the qualities that actors have. But it's also a little bit more specialized. Notice in the details panel, we have a classes section. And the game mode is what determines which of these classes are spawned by default. As you can see, the default pawn class is set to a class called default pawn. That's why every time we press play, we're able to move around and fly through the air. And if we detach, we can turn around and see that gray sphere. That is the default pawn that gets spawned in by default. Now, we have a game mode class, but we're not using it. And we can set the game mode per level. So if we go to testing level in world settings, we can choose the game mode to override here by opening the dropdown. And now our class, BP Bad Bot Game Mode, is available. And if we select that, we're now using our game mode. Now, we're not going to see any different behavior because we're still spawning the default pawn, which means we can still fly around. However, the level is now using our Bad Bot Game Mode, which has its own event graph, which means we can program our own functionality. We can prove that by printing a string off begin play. Let's print a string and say, Bad Bot Game Mode says hello. And we can go and play test and see Bad Bot Game Mode says hello. So that proves that this level is using our game mode. Now, we can set the game mode per level, as mentioned. We can also set a default game mode for all levels in our project. If we go to Edit, choose Project Settings, and we go to Maps and Modes. We've seen maps and modes before, where we can set the default map for our project. That's the maps part. But the modes part encompasses other classes, such as the game mode. And the default game mode for our project is set to game mode base. That's the base class that we based Bad Bot Game Mode off of. But we can change this to BadBot Game Mode, and now BadBot Game Mode will be used in all levels by default in our BadBot project, provided that we haven't overridden them at the map level. What do I mean by that? Well, I mean what we did in here. We came into world settings, changed the game mode override to a specific class here, and we just happened to set it to the same class that our project default specifies. But if we were to say set it to something else, well, now that takes precedence over the game mode and project settings. And that goes for any property that has been overridden, and you can tell that it has if there's the curved arrow to the right. We can always click that curved arrow to reset something to its default, and now we have our game mode override set to none. We'll default to the project settings determined game mode, and we can once again add a print string here. In our game mode, I'll just let it say hello this time, and show that now that game mode override is set to none, if I press play, I get hello, because it's defaulting to the game mode determined here in project settings, as long as we haven't overridden it here with game mode override. Okay, I think you get the point. So I'm going to close project settings, and here in BadBot Game Mode, I'd like to keep score for our player. Now, as you learn more about Unreal Engine and the different classes that exist, you'll learn other ways to keep score and perhaps other classes that you can keep the score count on. For now, it's perfectly fine that we keep the score for the one and only player in this single player game on the game mode, and we can keep that as a variable. And for whole numbers that are not fractional, we can choose an integer for that. So I'm going to click plus to add a variable. I'm going to call this player score and change its type to an integer. And I'm going to create a handy function on the game mode to increment the player score. And while we're at it, print a debug message to the screen to show it. So I'm going to add a function to my BadBot game mode. So clicking add, adding a new function, and I'm going to call this increment score. And I'd like to take my player score and set it equal to itself plus 1. So I'm going to get a set player score here. And I want to set it to what it was before, so I can use a get node, and I can add 1 to it. So using an add node and setting this to 1 and hooking this up. This is how we can take our player score and increment it by 1. We first calculate how much the player score plus 1 would be, and then we set the player score here. Now, there's actually a single node that will increment a variable and set it equal to itself plus 1, and that is the plus plus node. If I take player score and drag off of it and type plus plus, we get an increment int. And this does the same thing as these 3 nodes. So it's more compact in that it takes 2 nodes instead of 3, but both of these do the exact same thing. But the compact version is kind of nice, so we'll go ahead and use that one. So increment score takes the player score, increments it by 1, and then I'd like to simply print a string that says what the player score is. I'm going to use an append string node. And I'm going to say score colon space and take my player score, convert it to a string by dragging it in like so. And I'm going to hook that into print string. So now if our increment score function ever gets called, the player score that's stored on the game mode will be incremented, and it will be displayed to the screen with a debug message. Normally we'd have a HUD, a heads-up display in our screen showing things like progress bars and fancy numbers with specified fonts, possibly even animations, but we haven't gotten that far yet in our journey. So for now, we're just using print strings, and we'll learn more exciting things as our journey goes on. For now, it's enough to know that we're keeping track of the score and updating the screen with it. So when do we call increment score? Well, when our small spheres get destroyed, that's when I'd like to increment the score. And we know that in on-sphere overlap, we're checking if the other actor that overlapped is a pawn using isA. If it is a pawn, we wink out of existence. At the end of that timeline is when we destroy the actor, remember, in the wink out timeline. Well, before we wink out, I'd like to access the game mode, and I'd like to call that function on it increment score. So how do we access the game mode? Well, we can always access the game mode from any class by right-clicking anywhere in the event graph, typing get game mode, and using this utility, get game mode. It says returns the current game mode base or null if it can't be retrieved, such as on the client. Client is talking about a multiplayer game where there's a difference between the server and the client. But we're a single player game. We don't have to worry about that at this point. All we need to do is call get game mode, and we can be sure that it will always be valid because we always have a game mode. And we know that the game mode in our project being used is BadBot game mode. But there's a problem. Get game mode returns a value of a very specific data type. The type is game mode base. Now we know that our BP BadBot game mode is a game mode base. That's what we chose when we created a new blueprint. And in fact, we can check the class that any blueprint is based off of by going up to its class settings. And in the details panel, the parent class shows what this class is based off of. This one is based off of game mode base. So thanks to inheritance, we say that BadBot game mode is a game mode base. It inherits all the qualities of a game mode base, but it's more specialized. For one, it has an increment score function that we just added, right? So we know that BadBot game mode is a game mode base. And when we're in small sphere, if we call get game mode, we're retrieving the current game mode used by our project, which is a game mode base. So you might think that because our game mode has a function called increment score, that we can take this game mode value and search for increment score. But look, there's nothing there. Now, if we uncheck context sensitive, we can find the function that belongs to BP BadBot game mode. That class has an increment score, but the class called game mode base does not. If I try to select that, you'll see that there's no connecting wire, and no matter how hard you try, you will not be able to connect these two wires. In fact, we get a pop-up that says game mode base object reference, that's this one, is not compatible with BP BadBot game mode object reference. Well, we just saw that a BadBot game mode is a game mode base, right? So why isn't this working? Well, a BadBot game mode is a game mode base, yes, but a game mode base is not a BadBot game mode. It doesn't go both ways. The parent class, game mode base, has nothing to do with BadBot game mode. It doesn't have any idea about BadBot game mode or its increment score function. What we need is a value of this type, BadBot game mode. It needs to be more specific. So how do we take a value of the parent type, game mode base, and convert it to a BadBot game mode? We know that this game mode being used is a BadBot game mode. It's just in the form of the wrong data type. Well, that's where a concept called casting comes into play. You see, if we know that the game mode being used by our project and returned by this node is a BadBot game mode, but it's in the form of its parent class, we can cast it to BadBot game mode. We do that by dragging off and typing cast to. And we have to specify what we're casting to. We're casting to a specific data type, BP BadBot game mode. Don't choose the one that says class, choose BP BadBot game mode. Now, check this out. In order to cast, this has an input execution pin, so we have to let the flow of execution hit the cast node, okay? Now, there are two output execution pins, one regular one and one that says cast failed. So why would a cast fail? Well, it all has to do with the object being passed in. Is the object being passed in actually a BadBot game mode? Well, we know in this case that it is because that's the game mode being used by our project. So if we get that game mode, even though it's in the form of a parent class type game mode base, we know that it is indeed a BadBot game mode. So this cast is going to succeed. We're going to get the topmost execution pin executed. But let's say that we passed in something that was not a BadBot game mode. Like, oh, I don't know, a small sphere. If we right click and get a reference to self, I'm going to check context sensitive to make that easy to find it. This reference to self is a BP small sphere. That's its data type. If we hook that into the cast, this cast is definitely going to fail because a small sphere is not a BP BadBot game mode. See how that works? A cast will succeed or fail if the object being passed in is truthfully the data type we're trying to cast to. A small sphere is not. That cast will fail. That's a silly cast to try to make. But a game mode could be a BP BadBot game mode. In our case, we know it for sure is. See how that works? So casting is a way to take an object of one data type and convert it into another data type, but only if the object itself really is an object of that data type. Now, I know that sounds confusing, and everybody is confused with casting on their first try. Everybody, trust me. It's not going to sink in the first time you try to use a cast. But soon we're going to learn more about inheritance and the object hierarchy and how one object can inherit from another, and it's going to make more sense the more experience you get. But the first time you use a cast, you're almost certainly going to misunderstand it, but hopefully now you have an idea of what it does. So anyway, when our small sphere overlaps with a pawn, we're getting our game mode, casting it to BP BadBot game mode, which will succeed as long as our project is using the BP BadBot game mode class. And that means this topmost execution pin is going to be executed. And that means we can call a function because we now have the game mode in the form of a BadBot game mode. That's because the cast returns its value here. And with context sensitive on, I can search for increment score, and I can find it, and I can indeed connect the blue wires. See, look, game mode based data type doesn't work, doesn't hook up to increment score. BP BadBot game mode data type does because this function belongs to that class. That's the whole reason we wanted to cast in the first place. So we could call increment score. Once we've done that, then we can finish by winking out the sphere and we're done. And now we're keeping track of our score. Let's go ahead and give these nodes in our small sphere a nice little comment that says handle overlap and give it a color. Let's make it our nice little dark red. And I'm going to click show bubble for both of these comments. And all that's left to do is to test it out and see if our score increments as we collect these spheres. Let's see if we can get some. Here's one. There we go. Score 1. Let's get another one. Oh, score 2 and score 3. So it's working. Our game mode is keeping track of our score. This gives us a nice way to keep track of our progress as we're avoiding bullets. Well, not bullets, but blaster beams, right? So soon we're going to put all this together in one level and give it a try. So now that we're keeping score and we know a little bit about another class, the game mode, and how to access the game mode and cast to that game mode class that we're using so that we could call functions on our specific game mode, we've learned a lot of new information in a short period of time. And again, please don't be discouraged about this casting idea. Casting comes from programming. It specifically comes from object-oriented programming, where inheritance is a big deal and blueprints is object-oriented. We've seen that our pawn is an actor, but an actor is not a pawn. A BadBot game mode is a game mode base, but a game mode base is not a BadBot game mode. It's a one-way relationship. So again, we'll get more into inheritance and exactly how it works. But for now, you know how to cast a game mode to a more specified game mode class so we can access functions on it, which is a huge, huge milestone. So excellent, excellent job. And I'll see you in the next video.